All right, we're checking out the assignment on solving systems of equations by graphing on big ideas. So number 1, tell whether the ordered pair 8, 2 is a solution of the system of linear equations. Well, how you do that is that's the x, that's the y. You could graph these, but they want you to start out by plugging this stuff in. So 8 minus 2 equals 6. It is officially on that line. And if we do the other one, it would be 2 times 8 minus 10 times 2. That's 16 minus 20. That does not equal 4. So no, this is not a solution. Even though, yes, it was on this line, it is not on that line, which makes us not a solution. Next, same thing, different number. Tell if this is a solution to this system right here. So 3 negative 7 times negative 1 minus 4. Well, that would be 3 equals positive 7 minus 4. That works. This one is, the y is 3. 8 times negative 1 plus 5. 3 equals negative 8 plus 5. No, that does not work because that would be 3 equals negative 3, and that does not work. Next, there's x, there's y. So we have 6 times 5 plus 3 times negative 6. That's 30 minus 18, and that does equal 12. This is 4 times 5 minus 6. Does that equal 14? Well, 20 minus 6 sure does equal 14. So we have our first yes. And if you're like, wait, why? Because that's true and because that's true, it must be on both lines. Back up here, this one was true, so it is on that line. This one was not true, so it is not on this line. Now, it might be on that line at a different point, but it just doesn't happen to. Actually, I guess that's not true. Those x and y values might show up at a different place, but not at the same time. Okay. Tell whether these ordered pairs are a solution. So this is x and this is y. So 6 times 1/2 plus 5 times negative 2. Well, let's see. 6 times 1/2 is 3. 5 times negative 2 is negative 10. That's negative 7, and that's negative 7, so we're good here. 2 times 1/2 minus 4 times negative 2. Well, that is 1 plus 8, right? 2 times 1/2 is 1. Negative 4 times negative 2 is positive 8. So we get 9 equals negative 8. No, we do not. Now this is our x, this is our y. Negative 4 equals 6 times negative 2.5 plus 11. So does negative 4 equal negative 15 plus 11? It sure does. Let's try the other one. So x is negative 2.5. Y is negative 4. Does that equal negative 9? Let's see. We get negative 5 minus 4. That does equal negative 9. So we are, yes, that is a solution to that system. Use the graph to solve the system of linear equations. Well, let's do it. This first one, I mean, I guess technically speaking, we don't really need to verify the graphs, but I'm going to just real quick. If I do the x-intercept, if I do the y-intercept, it's negative 4, and if I do the x-intercept, it's 4. Okay, so this is that red line. Great. And then if I do the other one, let's make it green. The x-intercept is 1/4, and yep, it sure looks like it is. And the y-intercept is 1, which is right there. So wow, if we were to like follow the graphs, we definitely need to draw it through, and we'd have to guess. And in fact, we're still technically supposed to like guess and check and plug in. But this thing, sorry, drop the pen, is at 1, negative 1, 2, 3. 1, negative 3 is our guess. Let's plug it in now. So 1 minus negative 3, is that 4? Yes. 4 times 1 minus 3, is that 1? Yes, it is. So confirmed, that is our answer. Okay, so this time maybe I won't graph them, but here we go. There's where they intercept, which is -4, 5. So we think it's -4, 5. Let's plug it in. So they've written this as 6y plus 3x. So watch out. So it's 6 times 5 plus 3 times -4. If you're wondering, like, oh, dang, Mr. McMath had a good catch there. Yeah, I had a good catch only after screwing it up first, right? Great. So 30 minus 12 is, in fact, 18. So that is on the line. Cool. And the other one, the x is -4 plus 4 times 5. Does that equal 24? Well, yes, 4 plus 20 equals 24. So we are confirmed that is our answer. We've reached one where you need to graph, and I hope that you either had good success with this and you're like, I'm a pro at graphing. If not, you need 100% to be doing this by hand. So the first line is in slope-intercept form. Its y-intercept is 7. Its slope is -1. So that's pretty straightforward. Let's graph this thing. That is not a line, that is a square. Let's try it again. There we go. There is our line, okay? And now the other one, let's make it green. It's also in slope-intercept form, pretty straightforward. The slope is 1, so we're already pretty sure of our answer here. But let's go ahead and throw the line on there just anyway. We're pretty sure that the solution is at 3, 4. Okay, so 3, 4 is what we think the solution is, but just to be sure, let's plug it in. Does 4 equal -3 plus 7? Yes. Does 4 equal 3 plus 1? Yes. So we are confirmed. That is our solution. Next, +4 is the y-intercept, and then it goes down 1 over 1 after that. Let's graph this thing. Come on. There we go. Something like that, and then something like that just in case, right? All right, and the other one is also in slope-intercept form. Let's make it blue. The y-intercept is -8. The slope is 2. So we're pretty sure we've already found a solution, but just in case, let's go ahead and slap the line on there. Okay, so I say we're pretty sure because it looks like it is 4, 0 right there, yeah? So let's plug it in just to be safe. X 4, Y 0. So here we go. 0 equals -4 plus 4. It sure does. And let's do the other one. 0 equals 2 times 4 minus 8. It also does. So we are confirmed that 4, 0 is our solution. We have another one in slope-intercept form. The first one, the top one, has a y-intercept of 2 and a slope of 1/3. Rise up 1, run over 3, rise up 1, run over 3. Just like that. So let's graph it. Come on now. Like that. Okay. And the other one, let's do it in blue. The y-intercept is 5. Slope is 2/3. Rise 2, run 3. Rise 2, run 3. 2, run 3. Rise 2, run 3. 2, run 3. Okay, this one's a little bit more interesting because, well, can I not graph? Is that what just happened? Let's look at it one more time. Y-intercept of 5. Rise 2, run 3. Got that. Rise 2, run 1, 2, 3. Rise 2, run 1, 2, 3. Yeah, I did not do this one quite perfectly. So here we go. Let's try it again. Down 2 over 3. There we go. All right. Looks a little better now. Like that. Okay. So why did it look a little more interesting? Well, because I screwed up. But now it doesn't look as interesting because it looks like it's pretty much -9, -1. And let's double check that that's true. So x is 9, negative 9. So 1/3 times negative 9, that's negative 3. And negative 3 plus 2 is negative 1. So that one's good. 2/3 times negative 9, that's negative 6. Negative 6 plus 5 is negative 1. That one's good. So our solution of negative 9, negative 1 is confirmed. Next, y-intercept negative 4, and the slope is 3/4. Rise 3, run 4. Rise 1, 2, 3, run 4. Okay. Looks like that. Looks like that, okay? The other one has a y-intercept of 11 and a slope of negative 1/2. Rise 1, run 2, rise 1, run 2. So you know what? Just to keep things interesting, I'm just going to do that. And let's just hope I'm right, instead of drawing it all the way across. So again, my estimation is 12, 1, 2, 3, 4, 5. 12, 5. Let's check the scale of the graph. Yep, there's 5. So let's plug in 12, 5. So 3/4 of 12. Let's see, that's 9 minus 4. That equals 5. So we're good on that one. Negative 1/2 of 12 is negative 6 plus 11, and that equals 5. So we are confirmed. 12, 5 is the answer. All right, we got one that's not in slope-intercept form, so we got to do some thinking. The y-intercept of the first one is negative 1, right there. And let's see, zoom back up here, get rid of my scratching out. The x-intercept is negative 1/3. X-intercept, negative 1/3. So let's see. This is, you can kind of see some circles. That's in quarters, so 1/3 is here-ish. Negative 1/3, I should say. And in fact, how'd you get negative 1/3? Negative 3 divided by 9, because you would have to solve this that way. And that's negative 1/3. Okay, so there's that line. And the slope is like a little yikes, right? But if you think about it, we rose 1, ran negative 1/3. So if you were to divide by fractions like this, remember you flip it and you multiply. So the slope is negative 3. It's not that bad. You could have gone up 1/1/3 each time. That'd have been kind of ugly though. Instead, why not go up 3/1? There we go, up 3/1, up 3/1. All right, let's graph it like that. There we go. And the next one, our x-intercept is negative 2. And our y-intercept, well, that would be 4. Okay. This slope's a little bit easier to calculate. It's just up 1, 2, 3, 4 over 2. So it's just 2, up 2/1, up 2/1 like that. And again, we don't really need to get too crazy with it because there's a pretty obvious where do they cross type situation. And it's pretty obvious that they cross at negative 1, 2. So let's plug that in and see if we're right. So first we erase that. Negative 1, 2. Negative 1, 2. So when negative 9 plus 6, does that equal negative 3? It sure does. And in fact, whoa, slow down. 9 times negative 1 plus 3 times 2. That's what I did. In fact, I'll slow down on this one. 2 times negative 1 minus 2. So let's see, negative 2 minus 2, does that equal negative 4? It sure does. So we are confirmed that that is our solution right there. Solve by graphing. Our x-intercept is negative 1. Our y-intercept is 3. So clearly the slope is 3, So we'll go up 3 over 1, up 3 over 1. Just like that. Okay. The next one is our x-intercept is pretty easy. We don't even need to scratch it out. X is -6. And y is going to be -2. -6 divided by 3, -2. So this slope's a little crazier. Up 2, back 6. Well, that's up 3, back 1. So it's -1/3. So it would look like that right there. Let's graph it like this. And we're pretty sure that, we have like a fractional answer here. So I'm going to go with, we're maybe at about 1/2 here. So like 1.5. So y equals -1.5. And this looks like maybe, let's call it 2/3. So -1 2/3. So that's fun. Let's plug those in and see if we're right here. Let's see. In fact, I don't even have to do that because I've given you the answers and I know that that's wrong. My graph should look a little bit cleaner, even though I did my best. The answer is actually -1.5, -1.5. So that should be more like -1.5. So we can go ahead and prove that by plugging them both in. In fact, we shall. But by the way, what would have happened is I would have gotten that it worked for one, possibly, and did not work for the other, possibly. Or it would have not have worked for both, and we would have found out, oh, something's wrong. So, -1.5, -1.5. So what happens when you have 3 -1.5s? Let's see, that's -4.5. And then what happens when you have 9 -1.5s? I don't know. You get 13.5. By the way, that should be positive because it was a negative and a negative. And that does equal 9. Wow, what a coincidence. And then this one, okay, you get -1.5. And then 3 -1.5s again is still -4.5. I just did. Anyway, -1.5 minus 4/2 is -6. So boom, confirmed. -1.5 can be written that way. It can be written this way. It can be written this way. Whatever you want. Next, y equals -5.5. Let's see, just a reminder, Vux and Hoy. So Hoy is when you have y equals, that's going to be a horizontal line. So it's a y equals -5.5. So this one is going to go through right here. This one should be pretty easy to graph. There it is. Boom, we're halfway done graphing. That's awesome. This one, we can divide everything by 4 here if we want to. So we get x minus y equals whatever 22 divided by 4 is. I believe it's 5.5, right? So the x-intercept is 5.5, which is right there. The y-intercept is -5.5, which is right there. Spoiler alert, it's going to be quite a simple one, right? So let's get our graph on. In fact, I don't even want to check this one. Because does y equal negative? So here, hang on. X is 0, y is -5.5. Well, I guarantee it works for for this one, right? And then, I mean, we just kind of proved that it worked for this one as well. So there's your answer. 0, -5.5. Moving on. All right, our x-intercept is -1/2. Our y-intercept, let's see, if you have -1/2 and you divide that by -2, that is the same as +1/4. So our y-intercept is 1/4 right there. Now, since we've got a pretty nice grid here, it's pretty easy to just be like, hey, listen, it's up 1/2. But that's not, like the most helpful thing ever. So here's my point in saying any of that is we actually are rising 1/4, running 1/2, right? And so if you were dividing this again, it would be like this. Your slope is really 2/4 or 1/2. Just throwing that out there that you're truly rising a full 1 and running a full 2. It's just notice that our graph goes only to a full 2, right? So if we were to rise 1 from 0.25, we go up to 1.25. And sorry, you couldn't see me do that. If we started right here, we're going to go up a full 1 and run a full 2. And again, if you were to follow this up 1 block over 2 blocks, a 1, a 2, a 1, a 2, a 1, a 2, we did it. So let's graph this now. There we go, right there. And then the next one, again, like I did on the previous one, and maybe I went too quickly, that I said, hey, look, I can divide each of these by 4. And even though I got 5.5, I mean, who cares? That's okay to do. So what I'm going to do is I'm going to divide everything by 4 here to get negative x minus 2y equals 1/2, because 2 divided by 4 will be 1/2. And if you're like, but why would you do that? It just helps me a little bit. So my x-intercept is negative 1/2. Okay, so my x-intercept, oh look, it's negative 1/2 also. And my y-intercept is 1/2 divided by negative 2. So my y-intercept is negative 1/4. Okay, so it's right there. And again, kind of using that idea of down 1 block over 2. This has a slope of negative 1/2, by the way. How do I know that? Well, because this one was up 1/2, up 1/2, and this was down 1/2, positive, negative. There we go. Going to graph, but we don't really need to graph because we've already seen it. And we get that the intersection is negative 0.50 or negative 1/2, 0. So if we were to plug this in, does negative 1/2 minus 0 equal negative 1/2? It sure does. Does negative 1/2 times negative 4? Well, that equals 2, by the way. Does 2 minus 0 equal 2? It sure does. So we are confirmed that negative 1/2, 0 is our answer. Okay, describe the error, correct it. Okay, well, first thing, the solution is never just going to be, hey, x equals 2. Because where does x equals 2? Well, it would be this entire line. So it's not that. The answer could be 2, 3. And here's what I'm going to do. I'm going to check that the guy graphed these correctly first. So we'll do this one green. Negative 1, raise 2, run 1. Okay, that looks good. And then we'll make this one yellow. X is y-intercept's 1, the slope's 1. Okay, that's good. So then I'm pretty sure the solution is going to be, like I said, 2, 3. But, it wouldn't hurt us to plug it in. If x is 2, 2 times 2 is 4, 4 minus 1 is 3. That checks out. And we have 3 and 2 plus 1 is 3. That checks out. So, boom. There's our solution. What's the error? That is, you make a total of 16 2-point shots and 3-point shots in a basketball game. Your score total of 35 points. Which system can be used to find the number of P 2-point shots, the number of Q 3-point shots? Okay, so this is about points, and this is also, okay, hang on. So when I say this is about points and this is about points, here's what's going on is this 16 is the exact number of shots made. What type of shots? 2-point shots and 3-point shots. So P plus Q equals 16 is going to be correct. So why I mention that is because this is now bad and this is now bad. Okay. Now, from there, this is the points. That's about the points. Now, speaking of points, there's a 2-point and a 3-point shot. So 2P plus 3Q is going to equal 35. And so, boom, it is this one. And the reason that I kind of hesitated for a second is just got to double check, triple check that the number P of 2 points, so 2P, is represented correctly. Because check this out. Over here, the other possible answer, it just has them switched. So then explain your reasoning. Well, I hate to tell you, when I explain this out loud to you, that is me explaining my reasoning. So however you want to put all of that into words, boom, that will be explaining your reasoning. Okay, cool. This graph shows the total costs of ordering X keychains from 3 different websites. For what numbers of keychains are the costs the same at 2 different websites? Okay, and then they leave the blanks right here. So even if we didn't have the blanks, between A, because that's the blue one, between A and B, because that's the red one, that happens here. So between A and B, it happens at 1050. And then between, let's see, A and C, because this is the C one, it happens right here. And I'm going to erase that so I can kind of zoom in. Let's say that happens halfway up. So we'll call that 25. So, and then this is also half, that's 5. So 525, okay? And then actually there's one more because B and C cross right here-ish. And that happens at, let's see, 40 and call that 95. So X is 40, 95, and I should write that down here. B and C is 40 and 95. Okay, I'm going to clean that up just to be all tidy, neat and tidy. So the number of keychains that cost the same at 2 different websites, or 3 different websites, whatever, is going to be our X values. And why is it the X values? Well, because that's the number of keychains. And this is the number of keychains. So 5, 10, 40, okay? And then it just says explain. Well, okay, explain because that's where they all cross, right? And then how do you know answers in part A relate to systems of linear equations? It's where those lines cross. I guess how you could say it relates to systems of linear equations. Another way that I was thinking of is, it's not that they're going to all have, they don't all 3 intersect at one place. So, is how it doesn't relate, so to speak, and that there's not just one solution. So I'm kind of giving a couple different answers. Like, I like this answer, I like this answer. There's not just one solution. Is there anything else I could think of that I would say about this? No, I don't think so. So there you go. Let me know what questions you got. This kind of was a lengthy one, but you got this. See ya.